sometimes you need to perform just some operations with files that go beyond reading and writing data. So for example, you might need to find out information about a file, whether it exists, what the path of the file is, whether a given file is a directory or whatever. So Python provides path-related utilities to help you do this, and we're going to examine that now. So here in the editor, let's go ahead and open up the ospathutils.start. And you can see I've already imported some modules we're going to need to work on this example, and some of them you might already recognize from previous examples, and we've got a new one here named OS. So this module gives us the ability to work with operating system related features, and you can also see that I've imported the path module from the OS module. And we're also going to be working with some dates and times, and we'll learn about those a little bit. Just bear with me for now as we go through this example. So let's start with something really simple. Let's just print the name of the operating system. So I'm going to go ahead and print os.name. All right, so let's go ahead and save and run that before we do anything else. And when I run that, you can see that NT is being printed out because, believe it or not, the official name of Windows is actually NT internally. So that's the string that comes back when we print the OS name. So let's go ahead and do another example. Oh, by the way, this is going to be different based on your operating system. If you're running this on Linux or a Mac, you're going to see something different here. So I'm running on Windows, so this is the result that I see. Okay, so let's take a look at some path-related features. So let's go ahead and see if a particular item exists. Now, I ran the previous example, which created this text file here. So if you haven't done the previous example, you might want to do that one before you do this one. So what I'm going to do is print item exists, and then I'm going to create a string from the result of path.exists. And I'm going to check to see if textfile.txt exists, okay? And the path class right here, you can see I'm importing that separately from the OS module. So now I have access to all these path functions, and textfile.txt clearly does exist. And I'm also going to check to see whether it is a file versus being a directory. So I'll write item is a file, and path.is file. And once again, I'll pass in textfile.txt. And then we'll do the same thing to check whether it is a directory, which it clearly is not. So instead of calling is file, I'll call is dir. Right. So in each of these cases, I'm operating on the textfile.txt item. So again, if you didn't do the previous example, go do that so that you have this code. So let's save, and let's go ahead and run this. All right, so the item clearly exists. The item is a file. Oh, I made a little mistake there. This should say is a directory. All right, so let's run this again. All right, so it exists, it's a file, and it's not a directory. All right, so let's try a few more operations. Let's try getting the file's full path. So I'll print items path, and that is going to be path dot, I'm going to call the real path function for the textfile.txt item. And I'm also going to call the split function to separate the file name from the path. So I'll write items path and name, and I'll call path.split, and then I'll just pass in the result of real path, which is right here. So I'll just copy that and paste it into the split function call. All right, so let's go ahead and run that. All right, so here we can see that the items path is in my desktop exercise files folder, and the items path and name, we can see that that's a tuple, right? So the first is the path without the file name, and then the file name by itself. So it's really easy to split those from each other. Okay, let's go back to our code, and let's comment out some of these previous examples out to make it easier to read. All right, what we're going to do now is get information about the file's modification time. So what I'm going to do is use the path module to get the modification time of the file, and then I'm going to use the time class's ctime function to convert that into a readable time. Now, we haven't covered dates and times yet, but you can see that I've imported the classes to work with them, and we'll learn about those in a little while, but for now, just bear with me as I do this. So I'm going to write t equals, and I'm going to call the time class's ctime function, and I'm going to call the path class's getMtime, which means get the modification time of textfile.txt, and then I'll just simply print the result. And I'm also going to use the getModificationTime function to construct a datetime object using the fromTimestamp function that's built into the time class. So let's go ahead and do that. So I'm going to print out, and for this I'm going to use the datetimes module. Okay, and the datetime module actually has a datetime class in it. All right, so I've got datetime.datetime. I know it's a little confusing, but bear with me. And then I'm going to call fromTimestamp, and then the argument that I'm going to give the fromTimestamp function is this right here, path.getMtime of the file. So I'll copy that and I'll paste that into here. All right, so now I'm getting the modification time, and I'm going to print out a nice readable time, right? It's just a couple of different ways of accomplishing more or less the same thing. So let's go ahead and run this. And we can see that the modification timestamp being printed out using two different formats, right? So you can see that the file's modified, and here's a nice readable version, and then here is the result that comes from the timestamp. Okay, so one more example, and this time it's going to involve some date math. And again, we haven't really done the chapter on manipulating dates yet, so just bear with me on this. What I'm going to do is calculate how long ago the file was modified. So I'm going to create a variable named td, and I'm going to assign that to datetime.datetime, and I'm going to call the now function, and that will give me the current time, okay? So that's going to give me the current time that I have right now, and I'm going to subtract off datetime.datetimes class, and I'm going to call the fromTimestamp method again. So let's go ahead and copy this fromTimestamp call with the getPath function. All right, and I've got to make sure I get the right number of parentheses in there. So I'm going to copy that, and I'm going to paste that in here. So I'm taking the current time and subtracting off the modification time. So I'm performing math with the dates. And then what I'm going to do is print it has been, and then td, and then since the file was modified. And then I'm going to do one other thing. I'm going to print, let's give that space. I'm going to print or td dot, and I'm going to call the total seconds function, and I'm going to print out seconds, okay? So let's go ahead and run this, and what this is going to do is create, and we'll learn about this in a little bit, this is going to create a time delta, which is an amount of time, it's a span of time, and we'll learn about that later. But I can use this to figure out an amount of time by subtracting two dates from each other. So let's save this, and let's run it. Right, and you can see right here in the result that it has been more or less almost 17 minutes since the file was last modified, or 1,013 seconds since the file was last modified. So just to recap, right, we started off by seeing how easy it is to get information about the operating system, and then we used the path functions to learn some basic information about a file in our operating system's storage, and then we worked with some file paths to get the real path and split off the path from the file name. And then we worked with some times. We got the modification time of the file, and then figured out a way to calculate how long ago the item was modified using the dateTimes class now function.